Hi class. Today we are going to continue our lesson on probability. So far you've learned about theoretical probability, and today we're going to look a little bit at experimental probability. Right now you should be with a partner watching the video and should have a handout that will help guide you through today's lesson and experiments. The learning targets for today are as follows. 1. I can understand the concept of experimental probability. 2. I can use the formula of experimental probability. And 3. I can evaluate games of fairness and or unfairness. So let's review for a moment. Theoretical probability is what we learned as what you expect to happen. So let's consider the spinner on your screen. What would be the probability of landing on green? So if we recall what we learned over the past few days, there are 5 sections of this spinner. So there are a total of 5 possibilities, but only one green. So therefore, the probability of landing on a green would be 1 out of 5. But what is the experimental probability of what actually happens? And that's what we will investigate today. So experimental probability is the number of times the event, what you are working on, actually occurs over the number of trials. So actually how many times you try it. So let's consider this spinner. So what you are going to be asked to do is to spin a spinner a number of times and record those results. So if you go to the website that has been listed on your worksheet under Experiment 1, you are going to go to that website and then click To Spinner. Once you get to this website, if you scroll down, you should have a spinner that looks like this. Your spinner on your screen does not match the exact one that we had in this slide, so if you'd like to change it to match the data table that you have for results, you can click Change Spinner. Once you get to here, click on the text box that says orange because that is the color that does not match our current list. We click on that and go over here and click on one of the blues of your choice. So there's our blue. Go back in here. We don't want it to say orange. We want it to say blue. You can apply changes and it looks a little bit more along the lines of what we wanted. If you'd like to choose different colors, that is perfectly fine. Just make sure that your result table on your handout matches the colors on your screen. Let's get started. So we're going to actually try a few experiments. I would like you to do 20 experiments, please. That means you will be doing 20 spins. So first, let's see what I am talking about. So if I hit spin, my spinner for me stops on yellow. It may stop on something different for you. If we hit results, it's going to track our results. So you are going to do this 20 times. You're going to keep following this until you have 20 data points. If you would like, instead of pressing it each time yourself, you can hit a total, change the number of spins to 20, and it will do it for you at a much quicker pace, and it will track your results for you. Make sure to pause the video and do that now. Once you have all your data, I would like you to make sure that you've recorded your results in the chart given to you on your handout. So now let's think about what the experimental probability actually means for us. Let's suppose that what actually happened for you on landing on green was a 5 out of the 20 possible spins. Now we can reduce that because 5 goes into both 5 and 20 evenly. So 5 divided by 5 is going to give us a 1. 20 divided by 5 is going to give us a 4. So what this is telling us is that there's a 1 in 4 chance of landing on a green. If we recall from before, we previously had that there was a 1 in 5 chance of landing on a green. So I'd like you to take a moment and discuss with your group why the theoretical and experimental probability may have been different. This depends differently for each group on what your results gave you. I would like you to write down what you think you may be able to do to create the same or similar results between the two. Take a moment, pause the video, and do this now, please. Welcome back. So experimental probability, let's look at a few more options. Now if you go to the website listed as experiment 2 for you, we're going to take a look at coin tosses. You should come up with a website that looks like this. I just would like you to play around with this for a little bit and experiment with what a coin toss may look like. For example, if we look at number of tosses, if I wanted to toss this coin 5 times, we're going to click on and we're going to put in a 5 and we're going to say toss them. What this is going to do is show us the results. If you look down here, we see that our results were a heads, 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 then tails. We could do this as many times as we want, and we can either list them, show them in a table, or show them in a ratio. So according to our first experiment, there was a 4 in 5 chance of landing on a heads. But what we found in class the other day, that it's really a 50-50% chance. So what do you think this might mean? So what I'd like you to do is play around, do some more tosses. So say you want to do 5 more tosses, give them a go, and take a look at your data. So spend about 3 minutes doing this now. So pause and take a try with your partner. Now let's take a look at some more spinners, but maybe those spinners aren't quite equal. So if you go to experiment 3, I want you to go back to this website. We're going to go back to our spinner, so maybe you already have that up. And this time, I'm not going to let you worry so much about the colors. I want the colors to be different, but we're going to change the spinner so that all of our sections aren't even. So I'm going to change so my orange is actually 3 parts, and I'm going to apply that. So now I have a large section of orange and smaller sections of the other. So you may experiment this in different ways. And then I would like you to add in the colors of your charts onto the result handout that you have. And again, I want you to experiment with 20 spins. So we're going to spin, track our results, and I'm going to change this to a 20, and hit spin and let it show. So after a while, you will gather your data and fill in your chart, please. Now let's head to experiment 4. So now directions. I want you to play rock, paper, scissors with your partner. You're going to do this 20 times. I would like you to keep track of your wins, so you can use tally marks wherever you're most comfortable with, but to record your data. And at the end, I would like you to record the number of times player A wins over the number of trials, and reduce that if possible. Same with player B, and then the number of ties. Pause now to complete this experiment. So now that you've completed the rock, paper, scissors with 2-player possible outcomes, here's some things I'd like you to discuss with your partner. What were the possible outcomes in your experiment? What were the chances of you winning? Would you use this method to decide who would pay the bill at a restaurant? So would you do rock, paper, scissors with a friend to decide who would pay? How about if you wanted to use this to decide who passed the class and who failed the class? Would this be a fair way of deciding? I'd like you to take a moment, pause and discuss, and please write down your reflections of these discussion problems on the handout. So what happens if we change it up a little bit? So now you should have found a 3rd player, so the groups are split up a little bit differently, to try a 3rd game of rock, paper, scissors. So if we take a look at our rules, player A wins if all 3 hands, when you play rock, paper, scissors, are the same. For example, if all 3 of you have paper, then player A wins. If all 3 of you have something different, then player B wins, and player C wins if 2 of the hands are the same. So at this moment, please make sure you decide who is going to be player A, B, and C. I would like you to record your data on your chart, fill in the probability, experimental probability at the bottom. Complete this experiment now and pause the video. So now in your groups of 3, I'd like you to take a moment to discuss the following questions. What were the possible outcomes in your experiment? What were the chances of you winning? Did this change from your first time around? So did you have a higher or lower chance of winning? And now, what would you use this method to decide if you would pay for a bill at a restaurant? Why is that possibly changed? Does this seem fair now to use this as a method to decide who would pay for a bill at a restaurant? So last experiment. Let's look at the Monty Hall problem. So behind one of these doors is some money. And it is up to you to figure out which door to choose. So let's say, for example, you chose door number 2. So we are going to take away one of the other doors that you did not choose, either door 1 or 3. So if I take away door 3, oh, that's the pig. So we know that the money still has a chance of being behind door number 2. But your odds are now a little bit better, right? Now you have a 50-50 chance. Do you stay with door number 2, or do you switch your answer to door number 1? I say, do you know what? We're going to go ahead and we're going to switch our choice to door number 1. Behind door number 1 is another pig. We didn't win our money. All along, the money was behind door number 2. So I'd like you to take a moment, go to your last experiment here, and you're just going to practice a little bit. You're going to choose number of doors. So we're staying with 3 doors. So let's go back to 3. And we're going to say reset doors. Pick a door. I'm going to pick the first door here in the middle. So my pick was under door number 3, which means it could still be under door number 2. This time I'm actually going to stick with door number 2, and I won my money. Let's reset the doors, try again. This time I'm going to pick door number 1. So there's a pick up behind door number 2. Do I stay with door 1, switch to door 3? I'm going to switch to door 3, and I win my money. Great. So I want you to try this a couple times and take a look and see what your results are. You guys did a really great job today. I'm proud of your hard work. And so now, working in your groups of 3, I would like you to complete the experimental probability game handout and have some fun with it. And don't forget, we're learning about probability.